All right, now we're going to get into actually graphing piecewise defined functions. And when we graph, we're really just going to be putting this in Desmos. So the biggest thing is, do you know how to put in these piecewise functions into Desmos properly? Now, actually, before we get into the second example, I do want to go over a couple helpful Desmos key shortcuts. When you type in like less than or greater than, let me just bring the camera over here to my keyboard, you can use these two here. So you'll do shift less than or shift greater than for these two inequalities. But what happens when you want to use or need to type in an inequality that's an or equals to? So to type in a less than symbol into Desmos, you will simply type in your less than button that I just showed, and then you will type in equals, and it will automatically make it this one here. So to type in a greater than or equal to symbol, type greater than, and then put in equals, and it will put that line underneath. So that will kind of save you some time a little bit as we do these. Now, example 2, I pretty much did for you here. The first thing it asks is this function here is my f of x equals 2 if x is less than or equal to -2, and that f of x equals -3 if x is greater than -2. So you're simply going to type that in. Now, it almost looks exactly like what it is. Instead of f of x, though, we know that we can replace f of x with y. So I went ahead and put that as a y. And so the first one is y equals 2. And then to put in this inequality here, you're going to put in your fancy squiggly bracket, which I bring back over to the keypad here. It's these two buttons here. You'll do the fancy squiggly bracket and then the inequality just like you see. And then you'll do y equals -3 and then the inequality that you see. And so you should get to this graph right here. So I do want to kind of show you one thing about this. It tells you the breaking point is at this -2 right here. And so you can see that very easily on this graph that here when x equals -2, this is where my graph is shifting. This is its breaking point. You can see the top graph and then the bottom graph kind of breaks at that point right there. Okay, so that's kind of something I want you to pick up and notice. And then let me have the wrong share on here. Let me stop share real quick. And I need to share my screen. Okay, so now here we are in Desmos. I went ahead and typed it in so you didn't have to sit there and watch me do that. And I can go ahead and click on those for you so you can see them. And I'm going to clean up my graph. I'm going to make this bold. I'm going to take away my minor grid lines, and then I want this to be a step of 1. Okay, so here's my graph, and that looks a little bit more like what you have in the picture there. Now, there is a couple things I want to kind of make note here. The first thing is these graphs don't ever stop, right? If you scroll this way, that line's going to keep going forever that way. And this way over here, this line's going to keep going forever that way there. So that's one thing I want you to kind of notice is that those are going on forever. So here, I'm just going to put a little arrow. We need to know that that's going to go forever. And I'm going to put an arrow over here. This one's going forever. Now, the other thing that we need to be aware of that Desmos does not do for us are these open and closed circles that we talked about. Now, on this one, it does kind of show us, if you get on this red line here, I don't know if you're following along with me, but if you get on this red line here and you keep going, it will stop right here at -2, 2. So, and you can see that that is a nice solid closed circle. How do you know that that's there? Because it's less than or equal to. So I know on this red one here that we have a nice closed solid circle. And then this one shows that it's simply just greater than, but not or equals to. So this one's gonna have a hollow circle right there. You'll always have one closed, the rest will be open. Okay, so where am I going? If you slide along this blue and slide enough, you get that hollow circle showing right here, and it tells you undefined. So that's not part of its function here. Unfortunately, this doesn't always happen where it shows you this is a solid one and this is a open one. So you need to just follow the inequalities. The or equals to is the solid because it can equal. When it doesn't have that bar underneath, it can't equal. That's where your open circle goes. Okay, so that is something we're gonna have to put on our graphs. So that is the graphing portion. Okay, now part B wants us to find f of -3 and f of 2. So f of -3, you can do this one of two ways. You can use the function. If this is my x right here, x equals -3, which domain will that be a part of? Is x less than or equal to -2 or greater than -2? And that's less than. So it equals this function here. Now we would plug it in, but this one just simply equals 2. So this equals 2. You can also use your graph, right? If x is equal to -3, I have no graph below. But if I go up and meet that graph, what is my y? My y is 2. Okay, here, f of now 2 telling me that x equals 2. So I can either use this right here. If x equals 2, then x is greater than or equal to -2. So I'm using this function here. This function has no x. It just equals -3. Equals -3. Or you can use your graph. If x equals 2, here's where my x equals 2. This time I have no graph above it. So we're going to go down below. What is that y value? It is -3. So you can use the graph or the function. Okay, this one's a little confusing because the function is a horizontal linear line, but you can use either. Okay, now state the domain. I'm just going to write this one here. Spoiler, every domain for this class will be -infinity to +infinity. And you can use that graph to look at that. As you go from left to right, it's going from -infinity, because it's going to keep going forever. It equals something when x equals -2. Jumps down here. It's okay that this is a hollow circle because I do have a value for that function. So it really doesn't take a break. And then it's going to keep going forever here. Or you can look here. The domain is every number that is less than -2, that equals -2, and that is greater than -2. So my domain is all real numbers. Okay. This is the first example of graphing piecewise functions. We have 3 more examples of this. So see you for example 3.